Hey guys, in this lesson, we're going to learn how to multiply radicals and divide radicals. So when we multiply radicals, I like to equate it as multiplying fractions. So let's just remember how to multiply fractions. So if we have 2/5 times 1/3, we're simply going to multiply numerator times numerator and denominator times denominator. So in our first example, we're going to multiply like components. And what I mean by that, just like numerator times numerator, coefficient times coefficient. So we're going to multiply the 2 times the 5, and then we're going to multiply the radicands, 3 times 6. And then we're always going to simplify if possible. So we're going to break down 18 into 9 times 2. We're going to take the square root of 9, which is 3. And we're going to end up with 30 times the square root of 2. In our next example, we have a -3 times a 4 for our coefficients. We get -12. We're going to multiply the radicands together and get 50. We're going to rewrite 50 into a perfect square, and that's going to be 25 times 2, are the two factors. We're going to take the square root of 25, which is 5, and multiply it by -12. And we end up with -60 times the square root of 2. Now let's take a look at some where we have variables. And since we're multiplying variables, we will apply the product rule for exponents. So remember, the product rule says that we add exponents. So our coefficient is -1. There's an understood 1 right here. -1 times 2. Now let's multiply the radicals, the radicands. 3 times 2 is 6. X to the first times x to the third is x to the fourth. And 6 is simplified, but x to the fourth, we can break it down into x squared times x squared. When we take the square root of x squared, we get x. When we take the square root of this x squared, we get x, and we're left with radical 6. We're going to put these three factors and simplify them into two factors. Remember, we're going to add those, and we get -2 times x squared times the square root of 6. Okay, our next example, we have 1/2 times 4. 1/2 of 4 is 2. Our radicands, 6 times 2 is 12. A squared times a to the first is a to the third. B to the first times b to the third is b to the fourth. Let's rewrite this radicand. We have 4 times 3 times a squared times a times b squared times b squared. Let's take the square root of 4. That gives us 2. A squared gives us a. B squared gives us b. And b squared gives us b. And we're left with 3a. We're going to simplify all these factors. So we get 4 times a times b squared times the square root of 3a. Okay, guys, you pause the video. When we come back, we'll do these together. Okay, we have -3 times -1, that's +3. We have 5 times 8 gives us 40. We can rewrite 40 into 4 times 10, and we get the square root of 4 is 2 times 3 is 6, square roots of 10. Number 2, 2 times 5 is 10. 3a times 6a to the third, 3 times 6 is 18. A times a to the third is a to the fourth. We're going to break down 18 into 9 times 2. We can break down a to the fourth into a squared times a squared. The square root of 9 is 3 times 10. That gives us 30. The square root of a squared is a. The square root of a squared is a. And we're left with the square root of 2. Number 3, 1/2 times 6 is just 1/2 of 6, which is 3. We have 12 times 2 gives us 24. M to the second times m to the first is m to the third. We're going to rewrite 24 into 4 times 6. M to the third gets broken down into m squared times m. The square root of 4 is 2. 2 times 3 is 6. The square root of m squared is m. And we have 6m as a radicand as well. Number 4, we have -1 times -1 is +1. I'm not going to write it. It's understood. We have 8 times 2 is 16. A to the first times a to the first is a squared. And b to the first times b to the first is b squared. And guess what? All 3 of these factors are perfect squares. So I take the square root of 16 is 4. The square root of a squared is a. And the square root of b squared is b. I have no radical left. Okay, dividing radicals is not the same as dividing fractions, but it is very similar to multiplying radicals in the sense that you simply divide coefficients and then you divide radicals if possible. Now remember, if we couldn't divide this out and 3 could not divide into the radicand, the denominator could not divide and I was left with a radical, remember you would have to rationalize the denominator. But we'll look at that in just a few minutes. So we have 6 divided by 2. That gives us 3. Radical 3 divided into radical 24 gives us the square root of 8. We can rewrite 8 as 4 times 2. We take the square root of 4 and multiply it by the 3 times the square root of 2. Okay, our next example, this time we have some variables involved. So we're going to have to use the quotient rule for exponents, which says subtract exponents, the top minus the bottom. Okay, 9 divided by 3 is 3. 24 divided by 6 is 4. X to the 5th divided by x squared is x to the 3rd. I subtracted 5 minus 2. We can rewrite the x, 4 is perfect. We can rewrite x to the 3rd into x squared times x. The square root of 4 is 2. 2 times 3 is 6. The square root of x squared is x. So we are only left with the square root of x. Now pause the video and you try these. Okay, we are first going to divide the coefficients. 12 divided by 3 is 4. 36 divided by 3 is 12. We are going to rewrite 12 into 4 times 3. We're going to take the square root of 4, which is 2, and 2 times 4 is 8, times the square root of 3. Number 2, negative 18 divided by 9 is negative 2. 12 divided by 2 is 6. A squared divided by a to the first is a to the first. 6 and a cannot be broken down into any factors that are perfect, so we're finished. Number 3, 24 divided by 12 gives us 2. 48 divided by 3 is 16. A to the 4th divided by a to the 1st is a to the 3rd. So 16 is perfect, but a to the 3rd, we can break it down and create a perfect square. The square root of 16 is 4, and 4 times 2 is 8. The square root of a squared is a, and we're left with the square root of a. Number 4, 28 divided by 14 is 2. 20 divided by 5 is 4. b to the third divided by b squared. B to the first is b squared. The square root of 4 is perfect, so it's 2, and 2 times 2 is 4. The square root of b squared is just b, and we have no radical left. So remember, as I was talking about earlier, we can't divide this radical 5 into this radical 2, and we cannot leave a radical in the denominator. So we're going to rationalize the denominator, like we've talked about earlier. This creates an understood 1, and we can always multiply anything times 1 without changing the value or just changing the appearance. And so we get the square root of 25, which is a perfect square, which is the whole reason that we are multiplying by this radical. And this gives us 10. So we have the square root of 10 that cannot be simplified anymore, and the square root of 25 is 5. Now again, do not be tempted to divide this 5 into radical 10. They are two different types of numbers. This is a coefficient, and this is a radicand. If we had something on the outside other than the understood 1, like a 10 or a 5 or a 15, then we could simplify, but we're finished here. Okay, we cannot divide 6 into 5, so we're going to multiply just the radical part, the radicand here. Okay, we're not going to use the 2. You don't need to do that. We're just trying to make a perfect square, so we're multiplying it by itself, so we get 2 times the radical 36, and on top we get the square root of 30. The factors of 30, none of them are perfect squares, so we can't break that down anymore. The square root of 36 is 6, and 6 times 2 is 12. And again, don't try to simplify radical 30 and 12. 12 is a coefficient, 30 is a radicand. Okay, 2 more. We're going to rationalize by multiplying by 5w. Numerator and denominator making equivalent fractions. We have in the denominator 2 times 25w squared. And in the numerator, we have 3 as our coefficient. 8 times 5 is 40. W to the third times W to the first is W to the fourth. Now let's simplify. The square root of 25 times 2 is 10. And the square root of W squared is W. In our numerator, we can break this down into 4 and 10. So I'll just go ahead and write this out. The square root of 4 is 2. 2 times 3 is 6. And then we have W squared on the outside. And we have radical 10 is left. Mark that out. And then over 10W. Now, let's look at this. These are the coefficients. These are like components. So I can simplify here, and we need to. 2 can divide into each 6 and 10. So we get 3, and 2 into 10 is 5. W squared over W gives us just W. Remember, subtract 2 minus 1, and then radical 10. And you're good to go. In our last one, we're going to multiply by radical 2x. In our denominator, we'll get 3 times a perfect square number here. Again, that was our goal. And then in the numerator, negative 2. So we have 9 times 2, 18. X squared times x to the first, x to the third. The square root of 4 is 2. 2 times 3 is 6. The square root of x squared is x. Let's write out the numerator. 9 times 2 times x squared times x. The square root of 9 is 3. 3 times negative 2 is negative 6. The square root of x squared is x. Left with radical 2x. So we are going to simplify our coefficients. Negative 6x divided by 6x is negative 1. times radical 2x. And we no longer have any radicals in our denominator.